everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we will study about introduction to Karnaugh Map and method to construct K-map for 2, 3 and 4 variables. Let us have introduction about Karnaugh Map. Karnaugh Map we normally call it as a K-map. Why we need K-map? So we know that for the simplification of Boolean equation or Boolean function, if we use Boolean algebra for the simplification of Boolean function, then we have to go with different theorems of Boolean algebra as well as some other theorems like De Morgan's theorem. But then for complex Boolean function, it becomes very complicated and we have number of steps and then we can simplify the Boolean function. Instead, the second approach, that is with the K-map. With the K-map, we can simplify the Boolean function, a Boolean function having 2 variables, 3 variables or 4 variables. Beyond 4 variables, again K-map is not very much in use because again it becomes very complicated. Now let us have brief introduction about K-map. K-map is a graphical chart in tabular form. It is a graphical chart with number of cells, as well as K-map is a very systematic approach to simplify any given Boolean function. It has a number of cells and number of cells depend on number of variables in the Boolean function. Suppose we have n variables, then number of cells will be 2 raised to power n. And each cell has its unique binary number as well as equivalent decimal number. Each cell can be defined with either product term, and that is min term of the SOP expression of the Boolean function respective to its row and column, or it can be defined with a sum term, and that is max term of the POS expression of the Boolean function respective to its row and column. Now let us study the method to construct the K-map. Suppose we have 2 variables in the Boolean function. Suppose we have 2 variables, then as we discussed that number of cell, that is 2 raised to power 2. We have suppose n variables, then we go for 2 raised to power n. So we take base 2 and power as number of variables. So in this case 2 raised to power 2. So 2 multiplied by 2, that is 4. So we have 4 total number of cells. Meaning is 2 row and 2 column. Suppose we go for 3 variables, then number of cells, that is 2 raised to power 3. So we have total 8 number of cells. We have 2 row and 4 column. And if we go for 4 variables, then 2 raised to power 4. So we have 16 cell and we have 4 rows and 4 columns. Now let us construct K-map for 2 variables. In case of 2 variables, we know that we have total 4 number of cells, 2 row and 2 column. But before that, let us have a truth table. In case of 2 variables, we know that we have different 4 possibilities, and that is 0, 0, 0, 1, 1, 0 and 1, 1. Equivalent decimal number, it is 0, 1, 2 and 3. If we write a product term, 0 means complemented, 0 means complemented and 1 means uncomplemented. So if we take 0, 0, then we have A bar, B bar. In case of 0, 1, we have A bar, B. In case of 1, 0, it is A, B bar. And for 1, 1, it is AB. So again I repeat, 0 means complemented and 1 that is uncomplemented. And this all product terms will construct our K-map with either 2 variables, 3 variables or with 4 variables, and we take SOP expression of the Boolean function as a base. So now let us go for 2 variable K-map, 4 cell, and we have 2 rows and 2 columns. We have total 4 cells. We have 2 variables. So A and B. A is the most significant bit and B is the least significant bit. So on the horizontal side, we have A, values of A. So it can be either 0 or it can be 1. Same way, on the vertical side, we have values of B. So it also either 0 or 1. As I said, 0 is complemented and 1 is uncomplemented. So here we have 0 and these values are for A variable. So it is known as A bar. Same way, for 1 it is A. If we go downward for B, then 0 means B bar and 1 is B. Now let us define the product term of the each cell. Suppose we take a first cell. Then we start with the MSB. MSB is A. So from A we take a 0 and from B also we take a 0. So value of this first cell, binary value, that becomes 0, 0. And 0, 0, for 0, 0 we know that it is a bar, B bar. Product term is A bar, B bar. Same way, if we go for second cell, then from the A side, MSB, we take a 0 and from the B, we take a 1. So binary value of this cell becomes 0, 1. And equivalent product term, we can refer the table 0, 1, that is A bar B. And we can verify that also because here we have A bar and here we have B. Same way, for the next cell, from the A we take a 1 and from the B we take a 0. Binary value of this cell, that is 1, 0. And 1, 0 we know that it is AB bar. And last, we have 1 from the A and 1 from the B, and that is 1, 1. And product term for 1, 1, that is AB. We can verify that also. So now if we write equivalent decimal number, then we know that 0, 0 is 0, 0, 1 is 1, 1, 0 is 2, and 1, 1, that is 3. So we have to remember this also, how to construct a K-map for 2 variables. Then very easily we can construct and we can write the minterms of the given Boolean function. Now let us construct in similar way K-map for 3 variables. Before that, we know that when we have 3 variables, we have total 8 different input possibilities. We have input 3 variables, that is A, B, C. A is a most significant bit and C is least significant bit. We have 8 different possibilities, 0, 0, 0, 0, 0, 1 and up to 1, 1, 1. So if we write a decimal equivalent, then we know that 0, 1, 2, 3, 4, 5, 6 and 7 up to 7 we can write our equivalent decimal number. Same rule applied for a product term. 0 means complemented, 1 means uncomplemented. So for 0 0 0 we know that it is A bar, B bar and C bar, and similar way when we go up to 1 1 1 we have A, B and C. So now again we construct K-map for 3 variables. We know that in case of 3 variables we have total 8 cells. We have 2 row and 4 column. So we have first row and second row. So this is total 8 cells for the 3 variables. We take AB on the horizontal side and C on the vertical side. So for AB, if we write equivalent number, then we can write 0 0, 0 1. Now at this stage, one thing is very important and you should always notice that while constructing K-map, we can change only one value at a time. So 0 0, we have taken 0 1. So this 0 is converted to 1 and 0 is remain as it is. So at a time only one bit is allowed to change. So from 0 to 1 or from 1 to 0. So what we do is we write 1 0 at this position and 1 1 at this position, because if we check 0 1 here, so this 1 is kept as it is here and 0 is replaced with the 1. Again from 1 1 if we go to 1 0, then this first 1 is kept as it is and this 1 is changed into 0. So we write like this 0 0, 0 1, 1 0, 1 1. This is very important and you should always remember, if this is wrong, then your whole K-map and simplification goes wrong. For C, we take a downward value, so 0 and 1. So now we know that 0, that is complemented, and 1 is uncomplemented. So if we write product terms for each value of AB, then for 0 0 it is A bar and B bar. For 0 1 it is A bar, B. For 1 1 it is AB, and for 1 0 it is A, B bar. Same way for C, 0 means C bar and 1. Now if we write binary values for each cell, we have to follow ABC. A is most significant bit and C is least significant bit. So for binary numbers, we have to take AB from the horizontal plane, that is values of AB, and for C we have to follow this vertical plane. So for first cell we have to take value of AB 0 0 from the this way, and for value of C 0 can be taken. So if we write binary number or product, then we can write 0 0 0. In similar way, we can write for each cell 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0 and 1 1 1. Product term for each binary value, we know that for 0 0 0 it is A bar, B bar, C bar. Same way for 1 1 1 it is A, B, C, and that also we can verify from this table. And if we write equivalent decimal number, then for 0 0 0 we know that it is 0. For 0 0 1 1, same way 2, 3, 4, 5, 6, and for 1 1 1 it is 7. You should remember this pattern 0 1 2 3 4 5 6 7. Then it will be very easy to map the Boolean function and to simplify. Now if we go for 4 variables, then if we check the table, now we have 4 variables, so 0, 0, 0, 0. So we have total 16 terms, 0, 1, 2, 3, 4, 5, 6, 7, 8 terms we have written here. 0 is complemented, 1 is uncomplemented. So we have product terms A bar, B bar, C bar, D bar for 0, 0, 0, 0. Same way for 7, we know that it is 0, 1, 1, 1. So A bar, B, C and D. So we have product terms ready. Same way we go for 8 to 15. So again we have similar product terms. For 1, 1, 1, 1, we know that it is a equivalent decimal number is 15. So product is A, B, C, D. For 4 variables, we know that K-map has total 16 cells, 4 rows and 4 columns. So we have total 4 rows and 4 columns. So we have total 16 cells. And if we write now variables, then AB is taken on the horizontal plane as well as CD is taken on the vertical plane. We write binary equivalent values for each bit for AB, then we can write 0, 0, 0, 1. Now this is very important, 1, 0 and 1, 1. You should notice this change. Same way, if we go downward for the CD binary bit value, then we can write 0, 0, 0, 1, 1, 0 and 1, 1. If we write product terms, then for 0, 0, we know that 0 means complemented. So A bar, B bar. For 0, 1, it is A bar, B. For 1, 0, it is A, B bar. And for 1, 1, it is A, B. Same way if we go for CD, then for 0, 0, C bar, D bar. For 0, 1, C bar, D. For 1, 0, C, D bar. And for 1, 1, it is C, D. So after this, if we write equivalent binary number of each cell, we know that in case of A, B, C, D, A is most significant bit and D is the least significant bit. So we follow writing A, B, C, D. So first we have to take values from AB, and that is from the horizontal plane, and then we have to add product term for CD, and that we have to take from the vertical plane. Product term of each cell, that is respective to its position and respective to its row and column. So if we discuss for this first cell, then we have to take 0, 0 from the AB and 0, 0 again from the CD. So if we write binary equivalent product for first cell, then we know that it is 0, 0, 0, 0. And if we write equivalent product terms, then we know that it is A bar, B bar, C bar and D bar. For each cell, we can go in similar way. Then we can write 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 1, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 1 and 1, 1, 1, 0. For each cell, accordingly, we can write our product terms in ABCD form, right? 0, that is complemented, 1 is uncomplemented. And if we write equivalent decimal number, then for 0, 0, 0, 0, we know that it is a 0, 1, 2 and 3. You should always notice this change, and you try to memorize decimal equivalent values for each cell. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and last 15. So pattern of writing decimal equivalent values, that should be very much clear to you. So thank you for watching my video. Keep watching. If you like, you can share and you can subscribe my channel. Thank you very much.